First thing in this question is we need to recognize our powers. 81 is 3 to the power of 4, and 16 is 2 to the power of 4. So we can rewrite the left-hand side like this. We also need to be able to recognize that 32 is 2 to the power of 5, and 343 is 3 to the power of 5. These powers of 2 are very, very useful to know, and similarly these powers of 3, they come up quite a bit in these types of questions. We need to look at what's the same, what's different about the left-hand side and the right-hand side, and we can see there's a lot of similarities here, but there are also some differences. If I could get the left-hand side to equal the right-hand side, or look more similar to the right-hand side, then we would probably be able to solve this equation. Remember, if x to, let's say, a equals x to b, then we can imply that a will equal b. So if I can get this to equal this, then whatever the powers are here, we can use that to solve the equation, and it becomes much more simpler. So that's what I'm going to do. That's the overarching aim or method that I'm going to keep in the back of my mind. Let's try and manipulate this now so that these are the same. Well, first of all, if I do one thing to one side, I must do the same thing to the other side. That's a fundamental rule, if you like, of equations. So if I was, for example, to multiply the left-hand side by something, I'd have to do the same to the right-hand side. So I'm going to multiply the left-hand side by 4 over 5. I'm going to raise the power of the right-hand side to 4 over 5, and I'm going to do the same to the left-hand side here. So raise a power on the right-hand side, have to do the same to the left-hand side. Notice I chose 4 over 5 because I know that this here, for my index rules, so a to the n to the m is the same as multiplying these two powers together. So here I know that 2 to the 5 multiplied by 4 over 5 will equal 2 to the 4. So this here, 2 to the 5 over 3 to the 5 to the 4 over 5 will equal 2 to the 4 over 3 to the 4. But because I've because I've raised this side to the 4 over 5, I have to raise this side to the 4 over 5. Now multiply this out and I would get so they're starting to look much more similar. What I'm noticing now is this is the reciprocal of this. The left-hand side is the reciprocal of the right-hand side, or vice versa, inside the bracket. 2 over 4 over 3 over 4 is the reciprocal of 3 over 4 over 2 over 4. So again, using my rules of powers, a to the minus m equals 1 over a to the m. In this case, we could say that a to the minus 1 equals 1 over a. If I raise it to the power of minus 1, I would end up with 3 to the 4 over 2 to the 4. It would be the reciprocal. So what I do to one side, I must do to the other. Do this, and I'd end up with 3 to the 4 over 2 to the 4 to the minus 4 over 5n, just multiplying these together, would equal 3 to the 4 over 2 to the 4. Now here I've got what I wanted, which was x to the a equals x to the b, so therefore I can say a equals b. And this side here, of course, is raised to the power 1. Raise any number to the power 1, it will equal that number. A to the 1 equals a. So I end up here with these two are equal. The x, if you like, here, the base is equal. So minus 4 over 5n equals 1. So therefore minus 4n equals 5, which implies that n equals minus 5 over 4. And I can, if I want to check this, of course, I can substitute this value here, minus 5 over 4, into my original question, plug that into a calculator, and I do indeed get 32 over 343.